Hey guys, Mr. Klein here, and we are back with Weather Patterns, Chapter 13, Lesson 2. Let's go ahead and let's get started with this. By the end of this lesson, you will be able to answer these four questions. What are two types of pressure systems? What drives weather patterns? And why is it useful to understand weather patterns? And what are some examples of severe weather? Now, whenever we talked about weather, we talked about things that we use to measure weather, the atmospheric conditions, things like temperature, air pressure, humidity, wind direction, wind speed, things like that. But those represent larger trends that we see in terms of weather. Why does the weather change? At the time that I'm recording this, this is wintertime in Louisiana, where we'll be warm in the 50s or 60s Fahrenheit, and then a cold front and a bunch of rain will push through, and we'll have 2 or 3 days of really cool or even cold weather with clear skies and lots of sunshine. What causes that to happen? And so that's what we're going to be discussing in this. And really, weather is often associated with what we call pressure systems. These are different areas of high or low pressure air. And a lot of times if you hear this stuff on the news with your weatherman or your meteorologist, you're kind of used to these terms already, but we're going to discuss them in a little more detail. So let's go ahead and let's get going with these. High pressure system is a large body of circulating air with high pressure at its center and lower pressure outside the center. What ends up happening is at the very center of it, you will have high pressure air right here, and it's pushing down, and lower pressure air goes out. High pressure air pushes down from above. It's kind of a downdraft. It pushes down, and it goes in a clockwise motion in the northern hemisphere, but counterclockwise in the southern hemisphere. What we have right here, this is New Zealand off to the right, but this is an example of a real high pressure system, a really strong one. So right here is the high pressure, and pushing out of it is the lower air pressure, so that's where those clouds are at. The easy way to remember this is that at the center of the high pressure system, the air is really dense. And so as you saw in that, the air is so dense, there's not a lot of room for a lot of water vapor, so there isn't a lot of room for clouds to form. In high pressure systems, skies are generally clear, and the weather is generally pleasant, fair conditions. You might have a couple of clouds here and there and things like that, but not a lot of them. So especially where we're at, especially in the United States in the wintertime, once you have a snowstorm blow through and you have sunshine and you got clear skies or you got some cirrus clouds way up there, that's as a result of a high pressure system, and so skies are really nice. Now, on the other hand, a low pressure system, that's a large body of circulating air also, but low pressure is at the center, not high pressure. High pressure is actually on the outside. The easy way to remember is at the center of the low pressure system, the air is rising. It's lifting up. In addition, in the northern hemisphere, it rotates counterclockwise. So what happens is, as you see on the outside of a low pressure system, they have higher pressure, and the closer you get to it, the lower pressure it is. And a good example, of course, of that would be like a hurricane, which we're going to talk about later in class. In low pressure systems, there is sometimes precipitation like rain or snow. Whenever we do talk about weather events in terms of, thunderstorms, hurricanes, blizzards, things like that, those are always associated with low pressure systems. You're not going to have a high pressure system move through and sit on top of you and dump a foot of rain or a foot of snow. That's not going to happen. A low pressure system, however, that's where you have precipitation, things like that, because water and heat is rising, forming clouds. And when we talk about thunderstorms, we'll talk about the three layers of cyclogenesis, which, the cumulus layer and things like that. But we'll get to that in a minute. Okay, so air masses. Weather patterns are the result of air masses. And essentially, air masses are large bodies of air that have uniform temperature, humidity, and pressure. So whenever you hear your weatherman on the television say, well, high pressure is going to be moving in for the next 3 days. Well, what that is, it's a big area. It's an air mass of equal temperature, pressure, and humidity. Like high and low pressure systems, air masses can extend for 1,000 kilometers or more. Oftentimes when you see the weather, we'll see very large scale air masses moving through. And so what we're going to do in this lesson is we're going to talk about, at this point right here, we're going to talk about the different air masses that dominate in the United States and how our weather is driven by them. But there's a handy guide to them. Let's go through the notes and then we'll get to them. Air masses are classified according to their temperature and their moisture characteristics, whether they're cold, cool, or warm, and whether they're wet or dry. Okay, so there are 6 types. The first one, the one where we get the coldest weather, is the Arctic or the polar air masses. Okay, they form in Siberia and the Arctic, and they contain bitterly cold and dry air with temperatures as low as 40 degrees Celsius. Oftentimes we'll find these up around the North Pole and things like that. They oftentimes will push in when you have the super bitterly cold weather in the northern United States. You'll get that very, very rarely where we're at in South Louisiana will we get these. Arctic or polar air masses, whenever they push in, very, very rare. Whenever usually our coldest temperatures on record in Louisiana have that. So the Arctic or polar air mass is origin Arctic Circle or Siberia. It's very cold, but it's also very dry. And if we look at this map of the United States, these Arctic or polar air masses will be right here. Okay, they'll originate in this area and they'll push down. So the next one are what we call continental polar air masses. They're fast moving, and they bring dry weather with cold weather in the winter and cool weather in the summer. This one really, the continental polar air masses are what dominates Canadian weather, and especially in Western Canada, and in most of the northern United States across, this is what affects it. What you have is cold in the winter, cool in the summer, and it's also very dry because it's continental. It's over land, so there isn't a lot of moisture being picked up. And this is what this looks like in this area. It originates over northern Canada, north central Canada, and pushes down. In Louisiana, this is whenever we hear Arctic fronts and things like that. This is generally where we get our cold weather in the winter. Whenever we have frost or freezing temperatures, the few times we have winter precipitation, it's because a continental polar system has moved into the region. Now, what can happen, this is the other the other polar air mass. This is the maritime polar air mass. It can form in the Atlantic and the Pacific. Most of the United States is dominated by the Pacific air masses. These are Pacific fronts during the winter. They bring cool and humid air with them because it's over water. That's where you get the moisture, so they tend to be more humid. And also because they're more humid, the temperatures aren't as low. Conditions are often cloudy and rainy, and temperatures in this mass, like I said, are warmer than continental air masses that originate in the region. What will happen is during the wintertime especially, these maritime polar air masses will originate in below Alaska, around British Columbia, and here by Washington State, and they'll move across the Rockies, and they'll, depending on the jet stream, they'll dip down in the southern Louisiana where we're at. And they're cool and humid. Oftentimes they'll have rain. That's usually whenever we have a maritime polar front, a Pacific front will pass through in Louisiana. Temperatures, southern Louisiana, we'll get temperatures in the mid-30s at the coldest, up into the 40s. It'll be clear for a couple days, but it won't be as bitterly dry and cold there. Now, when we talk about the polar air masses right there, what we're going to talk about now are the tropical air masses. The continental tropical tends to form in dry desert land and bring hot, dry conditions to areas. They generally form in the summer, particularly in northern Mexico, and they'll push into the Rockies and stuff. Very rarely will Louisiana get this, and that's usually associated when we get our warmest temperatures with that. So that's in central and northern Mexico. It's warm and dry. And finally, the one that you saw is the maritime tropical air mass. They form in the Pacific, the Atlantic, and the Gulf of Mexico. Louisiana's weather, especially in the summer, is dominated by maritime tropical air masses, and even warm fronts that go in the winter when air masses push up from the south. They bring hot and humid air to the southeastern United States, and in the winter are responsible for heavy snowfall if they move further north because they are so humid. Generally, polar and Arctic air masses will not have as much moisture as the tropical ones. And so the maritime tropical here will push up into the southern United States, and we talk about Tornado Alley, that's where these two air masses collide, the continental polar and maritime tropical. Nor'easters, where you have really bad weather and big snowstorms in the wintertime in the northeast, are a result of these. And maritime tropical is what keeps this area of Southern California nice and damp. So here's your handy guide to North American air masses. If you want to pause it right here, go ahead and write the stuff down or take a screenshot or something like that. It would be a really good idea for that. As they move over land and ocean, air masses can actually change their characteristics. So what can happen is a maritime polar can come on shore in, let's say, British Columbia and move across Canada. As it gets over to dry land, it dries out and it turns from a maritime polar to a continental polar air mass. So that's air masses for you. That's the major air masses that dominate North America, Europe, Africa, South America, Central America, Australasia, all you guys, and Asia Pacific, you have different air masses that dominate your weather also, and they're broadly similar to these. So let's talk about fronts. Whenever you watch weather, the weatherman, a cold front is pushing through and things like that. And you're like, well, a front door? What do I get? Well, it was coined about 100 years ago by a Norwegian meteorologist. His name was Jacob Bjerkens. He was working to predict weather and began noticing that specific types of weather happen at the boundaries between different air masses. And because he was a military man, he used the military term for the boundary between opposing armies, and that's what we call a front. And so that's where the term front came from. So a weather front is simply this. A weather front is a boundary between two air masses where there are drastic weather changes that occur there. So it's not like it goes from hot to kind of warm. It's where it's warm to cold. That's a front that passes. And there are four major types of them we're going to talk about. And here's an example of a cold front pushing through. As you can see, this is these clouds right here are the dividing line between one air mass and the other one. It's a bit more drastic up here in the northern United States than it is in the southern, but you can see that difference right here. Where on one side this is kind of warmer air, on this side it's cooler air. So let's talk about the four types of fronts with this. First is a cold front, especially in the wintertime where we're studying this in Louisiana. This is what our weather is dominated by. It gets warm, cold front pushes through, cools off. These air masses move in. Now, when a cold air mass moves into a warmer air mass, a cold front occurs. Okay, so that's what a cold front is. Cold air moves faster than warm air, and so when it slams into the warm air, that's where you have a cold front occur. The cold air, because it's colder and more dense, and it's oftentimes associated with high pressure, will push down and it'll sink. And so what it does is it pushes that warm air up. And anytime you have a large amount of warm air lifting up, you're going to have the chance of severe weather. Whenever a cold front passes through, temperatures can drop as much as 10 degrees Celsius in a short time. In fact, I remember several years ago, we had a cold front pass through in Louisiana, and it had been really unseasonably warm. We had approached some record high temperatures, and this front was going to drop temperatures about 10, 15, 20 degrees, even 30 degrees in some cases within a couple hours. And it was associated with severe weather, and so the front moved through. And within the space of literally 3 minutes, the wind direction changed from the south, from a warm and humid wind to the north, and it was a cold and dry wind. In northern Louisiana, they had more severe weather. Where I was at in southern Louisiana, we just had like 15 minutes of real heavy rain, but you could actually see the doors, the windows condensate because the air had changed so rapidly. Because I had gone inside when the rain started, it was warm, and whenever I walked outside, whenever it had a slight drop in the rain, I went outside and you could literally feel it was cold, and it had changed so quickly. And so this is what cold fronts will look like. The air behind the cold front pushes down. Cloud development is in front of the front because that warm air is being pushed up. And as it gets up higher in the atmosphere, it cools off and the water vapor will condensate. And so because of this massive change in pressure, in temperature and pressure, you have a lot of wind. And so because wind is pushing air up and down, that's where you get the chance of severe weather. Whenever we have severe weather outbreaks in the United States in the winter and the summer, it's usually at the hands of a cold front. Now, warm fronts happen in Louisiana too, especially in the wintertime because of the tropical maritime air mass. It'll push back up from the continental polar. It's when warm air moves into a colder air mass. Warm air moves slower than cold air. The warm air rises as it rises above the warm air because it is less dense than the cold air mass. Weather conditions at warm fronts often result in steady snows or rains for several hours or even days. You don't have that sharp, severe weather, but rather you'll have more steady times of of rainy weather. And so this is what happens with the warm front. The warm air is pushing and the cold air is being pushed back. And so this air moves up and forms clouds and it rains. Oftentimes what you'll have is something similar to this at higher altitudes when southern Louisiana, when we get snow and freezing rain. So what happens is this clouds get up, they condense, they start raining, and then the rain falls inside this cold air. And so it freezes, so that's where you get the freezing rain. Now, because air masses are large, their movement is used to make weather predictions. We see where the differences in air pressure and see where the differences in temperature are, and we calculate the speed at how fast they're moving, and so that's what we use to help predict weather, which we're going to talk about in our next lesson on predicting the weather, what we use in the computers and things like that with that. So when a cold front passes, just expect it. Temperatures will be cooler for several days. Even if it's a Pacific front, it won't be cold, it'll be cooler rather. And when you hear a warm front pass through, the air will get more humid, okay, because cool air is oftentimes associated with dry air. But just to clear up a misunderstanding you might be having, a maritime polar air mass is still drier than a tropical maritime air mass because in the tropics there's more humidity and stuff. Now, what happens when weather fronts run into each other, or they might get stuck because of bigger air masses blocking their movement? Well, sometimes an approaching front will stall over an area for several days. When the front is stalled, it's called a stationary front. Okay, stationary front, weather's usually cloudy and rainy, and rain is constant with that. And so let me get you an example of that. This is a stationary front. So the cold air is pushing, the warm air is pushing back, and it's kind of stuck here. And what you have is you have light, steady rain in this area along this front. And the final one is, as a result of what I said earlier, that cold air moves faster than warm air. And so what will happen is when they run into each other while they're moving, like it catches up, it's what we call an occluded front. Okay, because it's kind of mixed up. Occluded fronts usually have some sort of precipitation. So if you got those notes down, we'll go ahead and we'll look at it. And this is an example of occluded front. The very cold air is pushing really quickly. Or colder air is pushing really quickly. It catches up with cold air, and cloud development forms in between these two gaps. And so what will happen is you might have one cold front moving, a second cold front will run behind it, it'll run into it, makes an occluded front, and so you'll have rain and stuff, and then it'll dry out and things like that. So that's weather fronts for you. Okay, so let's talk about when cold fronts pass through, we have severe weather. In the United States, we're constantly one way or the other in the United States, we're dealing with severe weather in one way or another. Events such as thunderstorms, tornadoes, hurricanes, and blizzards are called severe weather. Okay, so thunderstorms, tornadoes, hurricanes, and blizzards are the four events that we call severe weather. Okay, and so let's talk about thunderstorms. They're the most common. Pretty much wherever you're at in the United States, you will experience thunderstorms at one time or another. And a thunderstorm is a weather system with a cycle in three stages. The first one is what we call the cumulus stage. This is dominated by cloud formation and winds that we call updraft, where air currents move vertically away from the ground. What happens let's look at this right here. This is the cumulus stage. Is you have warm air pushing up, usually associated with a low pressure system. Okay, this warm air gets pushed up, and as it cools, it starts to condense and form clouds. And especially as a front moves, you have a lot of air in a lot of places, and you have a lot of wind, so it builds up. Once it builds up to a particular point, the cold air gets cold enough at a big difference, it starts pushing down. And that's downdrafts, where you'll have up and down drafts. And so what happens is warm air will push up to above the freezing line, it'll get really cold, and then it'll push down. That's whenever you have a thunderstorm, you feel cold air, maybe before the front goes. That's a downdraft because of that. So once it forms that big cumulonimbus cloud, that big thunderstorm cloud, that's when a thunderstorm reaches its mature stage. At this time, you'll have the heavy rains, the high winds, lightning dominate. Tornadoes can form at this time. Now, a mature thunderstorm is only mature for about 30 minutes. After this, they begin to fade or dissipate. What happens is it releases all of its energy, the updrafts will stop, the winds will die down, and the rain will weaken. But what can happen is when a line of thunderstorms goes is a thunderstorm cell, that's what the individual thunderstorm is called, it'll go through this life cycle, but they'll just keep on popping up all over the place. So this is what happens in the mature stage, okay? You have the updraft, the downdraft, and cumulonimbus clouds, really big, heavy rain, winds, lightning, thunder, tornadoes, things like that, and it dumps out all of its energy, and as this is dumping out, the rain dissipates from low to high. And so that's what will happen is if you see a thunderstorm, it'll rain itself out going from bottom to top. Now, let's talk about lightning. What happens with lightning is when the updraft, the water gets up above the freezing line, it freezes into ice crystals. They bump into each other, creating positively and negatively charged particles. Once enough static electricity is formed and it finds a release, that's when the lightning bolt will move usually between clouds. That's what we call cloud to ground lightning, or even between clouds. What happens most of the time is cloud to cloud lightning, but whenever we think of lightning, we usually think of cloud to ground lightning. Now, thunder, that's the result of it, because lightning's really, really hot, like 25,000 degrees Celsius. In some cases, thunder will occur when that lightning bolt passes. That temperature is so hot that the air quickly expands and contracts, and so that collision is where the clap of thunder is. A good rule of thumb is that if you see a lightning bolt and you count slowly, every 5 seconds is about 1 mile, because at usually about sea level, more or less, speed of sound moves at a mile every 5 seconds. So that's thunderstorms. Now, within thunderstorms, we'll have tornadoes. And a tornado is a violent vertical column of air in contact with the ground. The largest tornadoes and the most powerful ones will exceed more than 1,500 meters, or a kilometer and a half, or about a mile in diameter. Now, what happens, this is how tornadoes form, is during the mature stage of a thunderstorm, downdrafts can sometimes begin to rotate. As they're coming down, they start spinning. They might get wrapped up in warm air also. When this rotation happens, that's when we start having tornadic activity. Most times, this rotation does not touch the ground. And if you see it coming out of the sky, the rotation, but it doesn't touch the ground, it will be called a funnel cloud. Where we're at in Louisiana, we see a lot of funnel clouds, not a lot of tornadoes in extreme southern Louisiana. The further up you go, that is more likely, but we'll talk about that in a second. Okay, so what happens when it touches the ground is it actually forms a tornado. Okay, so you have warm air lifting up, you have downdrafts coming in and then sometimes the downdrafts will get caught and they'll get pushed back up, and so that's where the tornado happens. Okay, so that's kind of the idea of it. The rising and warming air gets caught together and forms a rotation. Now, because it is a low pressure system, tornado will rotate counterclockwise. But let's talk about the nation with the most tornadoes per year, the United States. Far and away the home of tornadoes, and that's mainly because of the collision of air masses over the central United States. An area from northern Texas, so essentially an area from, say, Omaha, Nebraska to Dallas, Texas, and then from the base of the Rocky Mountains over to about St. Louis, Memphis, the Mississippi River, or a little bit west of that, is what we call Tornado Alley. This area is where during the spring and summer cold air masses from Canada and warm air masses from the Gulf of Mexico will collide, creating conditions for severe weather. The darkest clouds I've ever seen was on a summer vacation in Kansas. It looked like a just the blackest cloud I had ever seen, and that was at a collision of those air masses. And I remember, for us, I mean, we're in South Louisiana for this, so if you live there, you understand why. But over there, you'll see houses built into the ground, and that's designed in order for a tornado to go through and it not destroy the house. And we measure tornadoes on a scale called the Fujita Intensity Scale, and now we use the Enhanced Fujita Intensity Scale. It changes some wind speeds and stuff like that a little bit. And they use F and numbers from 0 to 5, with 0 being the weakest, 5 being the strongest. F0 tornadoes will cause light damage, but F1 to F4 tornadoes cause moderate to devastating damage, including tearing roofs for homes. And the most severe tornadoes are classified as F5s. These storms can demolish concrete buildings and even strip the bark off of a tree. The bark off of a tree, gone. Joplin, Missouri in 2012 was subject to one. The tornadoes in Alabama in 2011-2012 were F4 and F5 tornadoes. Okay, so this is the enhanced Fujita scale. Wind speed 65 to 85 and 200 plus are to F5. So things are just blown away. If you see where actually F5 tornadoes, you'll actually see the ground where dirt was actually picked up and moved by an F5 tornado. So whenever you hear tornado watches, tornado warnings like that, they are really destructive, really powerful, and can kill you if you're not protected. Now, South Louisiana, we know lots about these. A large, organized, tropical, low-pressure system with winds of 74 miles per hour or more, or if you're using metric, 110 kilometers, is a hurricane. This school year, when this is recorded, we were subjected to Hurricane Isaac. The East Coast had to deal with Hurricane Sandy. If you're in Florida, if you've dealt with hurricanes, Texas, the whole Gulf Coast, you've dealt with those. Hurricanes typically form in the late summer over warm waters in the tropics. And so what will happen is you have, and I could go on for this for hours about hurricane creation, but they're essentially very organized areas of low pressure, and they move around and things like that. Now, the highest winds in a hurricane are near the center of the storm, called the eye. If you hear the eye of the hurricane, and yes, I'm recording this at school, so that's why you hear that bell. Eye of the hurricane, it actually has calm winds, and they're variable. And so what we're looking at right here, this is a diagram of a hurricane. Hurricane winds and rain are in this area. The strongest winds are near the eye. This is the eye wall. And winds get weaker the further out you go. And so what you do is you have lines of thunderstorms with winds in that hurricane. And inside the eye, like this photo, you see the eye, you see they have a little bit of clouds, but right around here, these dark clouds right here, that's where the strongest winds are in the eye wall of a hurricane. Now, one thing to know about hurricanes is actually, even though you have high winds, the winds don't often kill people, cause buildings collapse, things like that. What most fatalities from hurricanes occur from flooding. Hurricanes can dump a lot of rain. It can easily dump within a day, day and a half, over a foot of rain, and that could cause widespread flash flooding. It could rain really quick, and waters rise really quickly, and people don't pay attention to it, and they get washed away and flooded and drowned. Okay, so hurricanes are measured according to the Saffir-Simpson hurricane scale. Category 1 hurricanes are 74 to 95 miles per hour, 2, 96 to 110. 3 and above are major hurricanes, so any hurricane with over 111 miles an hour of maximum sustained winds over 60 seconds are major hurricanes. Category 5 would be category catastrophic. Those are very rare with that. And if you see on the right-hand side, we have storm surge. And because it's such a large area when it's over water, the winds will push the water. And when it comes on land, you essentially have a tidal wave that's known as a storm surge. And it varies widely. It varies on how deep the water is close to shore, how big the hurricane wind field is. So this is kind of a broad thing. Category 1 hurricanes can have essentially no storm surge or even 5, 6, 7, 8 feet. But whenever you get into major hurricanes, you are looking at over 10-foot storm surges consistently. And Category 5, you can have even bigger ones. But not all, Category 3s can have also, for example, Hurricane Katrina that flooded New Orleans. What a lot of people don't realize is that was a result of backwater flooding, but that wasn't the biggest storm surge. The biggest storm surge hit southern Mississippi, and I went and I did some rescue operations and things like that. And I could tell you near the top of an overpass, there was grass where the storm surge was at. So the storm surge is actually 30 feet high. And the water just moves in quickly. It sits there when the winds die down, it goes, and it causes massive amounts of damage. But hurricanes happen all over the world. And this is this really cool infographic I found. And it shows each dot is a hurricane and tropical storm since 1851. Most of the major hurricanes we see in that time are actually in the Atlantic Basin. They go through right here. Okay, so you see, but they also will turn off to the side and go on the northern Atlantic. In the Central Pacific, you'll have them, and some of them will go around Hawaii, but most of the time they just spin out in the open Pacific. In the Pacific, affecting the Philippines, China, Korea, and Japan, you have typhoons, which is the exact same thing. The strongest tropical cyclone ever was in the was in the Pacific. I think it was tropical typhoon. It was Typhoon Teepee, which was about the size. It was actually huge. It was about the size of half of the United States. In the southern Pacific, you have them. They go out to sea. They'll hit Fiji, the Samoa Islands, and occasionally they'll hit northern Australia. And then in the Indian Ocean, you'll have cyclones that wander out. Occasionally they'll hit Africa or they'll hit Madagascar. And then you'll have cyclones and stuff that will hit India. And then very occasionally you'll see them in Iran and things like that. So essentially, if you know, this is all in the tropical wind belt. Okay, so that's where they take place. You don't see hurricanes above that because you don't have a lot of tropical winds. So finally, and where we're at in Louisiana, this isn't a really big thing, but you never know. You might get moved up to a northern climate and have to deal with these during the winter. And it's essentially a large low pressure system with high winds, a lot of snow. So we call a blizzard, where freezing temperatures, strong winds, and blowing snow are associated with a weather system. You have snow drifts of like 5, 6, 7, 8, 10 feet. You can't see, and it's kind of like their winter equivalent of a hurricane. Severe weather safety. It's a good thing to watch the news, listen to the National Weather Service, things like that. If they say evacuate, it's a good thing to evacuate. If they tell you to take cover, you take cover. And you'll hear two things. One, what you'll hear is a severe weather watch. And a watch is essentially saying that severe weather is possible. It would be a hurricane, tornado, severe thunderstorm, whatever. That means, according to our calculations, this might happen. But if it's actually going to happen, like within the next 24 hours in the case of a hurricane, or it's happening right now, or they see a tornado, they will issue a warning. And that means that the described weather is actually happening at that moment. And especially if they give a tornado warning, severe thunderstorm warning, you take immediate precautions and keep you, yourself, your family safe. So let's go ahead and wrap up this lesson. I know it was really long. It's 30 minutes. It's the longest video I ever did. Actually, in my class, we're going to cover this over 3 days. So, if you took the notes in class, bear with me. If you're watching online, you're awesome because you actually listened to me for that long. By the end of this lesson, you would have been able to answer these questions. What are two types of pressure systems? Well, of course, they're high pressure and low pressure systems. What drives weather patterns? Well, it's the movement of air masses. And where those collide are what we call fronts. And why is it useful to understand these patterns? Well, it's understanding weather patterns makes forecasting more accurate, which we'll talk about in our next lesson. And finally, what are some examples of severe weather? Well, thunderstorms, tornadoes, hurricanes, and blizzards are that. Thank you so much for listening. And thank you for your time. Students, if you have any questions, let me know. You can shoot an email. You can drop comments if you have any questions, things like that. Thank you very much for watching.